everybody, and welcome to 4-Minute Physics. Okay, so in this video I'm going to talk you through isotopes and a little bit on atom history. Again, the plan is to do this in under 4 minutes, so we'll start the timer and get cracking. Okay, first thing to know is what is an isotope. So we need a definition of this. So an isotope is a version of the same element. In this element there's always going to be the same amount of protons, but there must be a different number of neutrons. Now, when we draw atoms, we already understand the idea of what we're actually putting: neutrons and protons in the nucleus in the centre and electrons orbiting around the outside. In these two diagrams, these two are isotopes of each other. Now, what I've drawn here are two isotopes of carbon. The first one here on the left-hand side is carbon 12. The 12, of course, represented by the mass number at the top there. In carbon there are always 6 protons, so the atomic number of carbon is 6, and that's represented by the 6 at the bottom. In another version of carbon, what we would call an isotope of carbon, we have got 14 as the mass number. The 6, of course, stays the same. It is the proton number, or the atomic number. This number 14 tells us how many there are in the centre in protons and neutrons, so in this case there must be 8 neutrons in carbon 14. Now this makes this particular version of carbon unstable. It is radioactive, and we'll come to radioactivity in a video later on. Okay, so that's isotopes, and I hope that makes sense. Do remember, of course, that isotopes can be kind of isotopes of carbon, as well as oxygen, as well as sulfur. Every element will have isotopes of itself. Okay, let's look at atom history now. So atoms were kind of the idea of atoms, if you like, was discovered by the Greeks, the ancient Greeks, where they came up with the word atom from their Greek word atomos, which meant undivisible or uncuttable. They thought that they couldn't break that down into anything smaller, and the atom was the smallest thing possible. Of course, we discovered things like the electron, which completely changed that view. And the new model of the atom was put forward, and we called it the plum pudding model. And this is this diagram here. The plum pudding model, the idea was a positive sphere, and throughout that positive sphere there were electrons dotted around inside. This model was then challenged, and it was proved that it wasn't correct, and they came up with the nuclear model of the atom, in which case we have a nucleus with positive protons and neutrons in the centre and electrons orbiting around the outside. How did we come up with this model? Well, we used a technique, an experiment called alpha scattering. And this experiment was conducted using gold foil, very thin gold foil, and we fired alpha particles at it. And it led to the discovery of the nuclear model. The experiment, broken down simply, was a thin layer of gold, in this case represented, these are all atoms of gold, and an alpha particle source. Now the alpha particles were fired at this gold nucleus, and what was recorded was that most of these particles would just go straight through the gold. But every now and again, one would deflect and take a slightly different path, and some even bounced straight back. So when we were recording these results, it was interesting to see the percentage of how many just went straight through and how many were deflected. This diagram now represents kind of the idea of how many went straight through, and in this case about 99.8 went straight through. Around about 0.19, 0.2% kind of were deflected away, and less than 0.01% were deflected at more than 90 degrees, almost straight back where they came from. Now this led Ernest Rutherford, who conducted this experiment, to conclude that the atom was in fact mostly empty space, and it had a positive nucleus that deflected the positive alpha particles. Right, wow, right down to the wire, but that was fine. So I hope that was helpful, and I hope that that has either helped you with revising, or if you haven't fully understood it in your lessons, it's helped clear up some of that understanding for you. Okay, in the next video I'm going to look at nuclear radiation and explain the key ideas behind all of that. So thank you for joining me on 4-Minute Physics. I'll see you next time. Cheers, bye.